Hello, everyone. Very good evening to all the participants and the panelists present over here. So I would first like to thanks Analytics Vidya for giving me the opportunity to present my ideas with everyone. So before I begin the session, I would like to mention a few things. So first of all, feature engineering is a very vast subject, and it is one of the most important subjects of machine learning. And of course, it is an art. So the one who is more artistic in creating features can obviously have better models. So 1 hour session obviously is not enough to get everything into you related to feature engineering. So I would be talking throughout the session and showing you a couple of examples. So I would suggest you keep your notepad or something at your hand so that you can write those few things out. So I would still like to give a small introduction. So I did my BTech in electronics engineering, but the data science field, how I came into it was completely a self based or a self dedicated thing. So after my third year, when I was in my third year in the sixth semester, I got introduced to data science. So this was in the year 2018, and from 2018 I started learning data science on my own. And to be very honest, I don't have a single certification or anything in data science. So you have all the resources, so and you just need time to invest in yourself. Now the expectations from this webinar is something like I am going to talk about the things which have helped me in creating good models, mainly in competitions. So in competitions we have the leaderboard, and it helps us to understand that how good our model is performing. And as you know that in most of the machine learning competitions, it is mostly dependent on the features, and then next comes the modeling part. Now before we create the features, there is some kind of data pre-processing involved, but that data pre-processing is usually not very similar to the real world data. In real world data, we usually spend a lot of time in pre-processing the data. So in case of competitions, usually you are given a much cleaner and much structured data in terms of training and testing. So as you can see, I have around 4 years of experience in data science, and uh, Trell is one of those startups where I started my corporate uh, corporate experience. So at the time when I joined Trell, it was a very small team, and now it has a lot of funding and a lot of employees as well. Most of you or many of you might know about Trell. And then after I finished my internship at Trell, I joined ZS Associates through an internship contest. So it was a online machine learning competition that they had hosted, through which I joined ZS. And similarly, Society General also had 2 rounds of machine learning competition, and post which I joined Society General as a full time. And it has been around 4 to 5 months that I have been working at Pfizer. So I'm going to share my experience and my learnings that I have. So I would be sure enough that whatever learnings I have in terms of feature engineering would be more practical and more application based. So it will also help you in understanding that how you can also think or solve any kind of data problems. So just to give an overview, what is feature engineering? It is basically to create variables that are not there in your training set. So when you have a trained data, you will have X number of columns. Now, X plus N, that N number of columns that you create from those X variables is what is known as feature extraction. And then what we do is we do a kind of feature selection before we develop our final model, because we don't want to keep highly correlated features, or we don't want to keep uh, we don't want to keep redundant features in our data set. Now, feature engineering, how it helps. So I have seen in a lot of competitions, or through discussions, I have understood that there are many people who directly jump into modeling. They really don't do the analysis. They think that XGBoost and LightGBM might, will be giving better results than SVM or any kind of linear classification models. But that is not the case. In many cases, we have seen that linear models, or rather I have seen that in many cases, in many competitions, linear models have turned out to be really good, and they have surpassed deep learning models or bagging and boosting models. So the reason that we focus so much on feature engineering is because we can have a robust model, and also when you have good features and when you have good results, it is very easy to explain to stakeholders or business people that, these are the features that I have come up with, and these are the insights that I have got. So it helps you overall increase the performance as well as increase the explainability of the model. Now, how do you find the right set of features for your problem statement? So there are many people working in different industries, and also the machine learning competitions that happen on Hacker Earth, Analytics Vidya, or even Kaggle. The problem statements obviously differ. Each problem is different and each problem is unique. So first and foremost that you need to remember is there's no thumb rule. So today, in case you come in the top 5 in a machine learning competition, you have a solution, you have a set of features, you have a thought process. That similar thought process or similar model is highly likely that it is not going to work in a problem which might be coming up. So on a new problem, this current solution is not going to work, and we say that there's no thumb rule that what might work today in this problem will not work tomorrow. Second is the intense EDA. So EDA is a very important part uh, in extracting the right kind of features. And obviously without EDA, just using normal features and creating a boosting or bagging model is simply not going to help you. And third point, which I found very useful for me, is to think like a human. So often we think that, we got the data set, we try to do EDA, we try to create features that may or may not make sense, but we just do it, right? We just get the data, we start doing EDA, we do pre-processing, we fill null values, and then we simply start to create features. Maybe we do addition of few columns, we try to multiply, we divide, and whatnot, right? But the most important thing that worked out for me was to think like a human. Now, think like a human is something like, you just forget that you are creating a machine learning model. You have the problem statement, you have the data columns. Now place yourself into that machine's place. Okay, so let's take a simple example. You are there is a very common problem statement called predicting the electricity charges, right? Now, predicting electricity is a very common problem statement, and you have a lot of variables in the data set, like number of appliances, then country, state, and many other things, right? But if you think like a human and use your common sense, don't you think that season will play an important role? Why? Because uh, in winters we use less air conditioner, we use less fan, whereas if it's a summer season, it's just the opposite. So as a human being, don't you think that the electricity bill will differ from season to season, right? And just you getting number of appliances, or the timestamp, whether it's day, night, evening, more important here will be the season, because as a human being, you are also thinking that the electricity bill varies from season to season. Similarly, for a machine also, it will be very easy for the machine to capture the season and understand that the electricity bill varies from season to season. So this is just a simple example that I'm trying to give. And the similar think that thinking like a human point of view is very, very effective, and it is a must try. So whenever next time you participate in any competition, or whenever you are solving any business statement, just think like a human. Just try to understand that what would have helped me to learn it better, right? When we are, let's say, when we are trying to predict the gender, we are trying to see what is the height, what is the hair length, what is the voice, etc., etc. So similarly, when you're solving a business problem, just try to think that how would you be able to learn it in an easier way. Similarly, just place it in terms of model, and this is a huge trick that has worked for me. And obviously, I am pretty sure that when you also try to do this, it is going to work for you. And this is something which comes from practice. So again, there's no thumb rule in this. You just need to solve a lot of problems, you just need to think. And the more you solve, the more you practice, then only you will get the realization from time to time. And the fourth point that I have to tell is trust your instincts. So you have a problem statement, you get a data science problem statement. Now there are five other people who are also involved in that competition, let's say. Now the other four people might have a different thought process, right? When they're trying to solve the problem statement, they will have a different thought process, and you will have your own thought process. Don't just combine both of the thought processes. Don't, when if you are discussing it with the other people, just try to understand, or maybe get insights how they are thinking about the problem. But let's say if they tell you that this feature is working great for my model, it may or may not work for you, because the thought process involved might be different, right? How he is approaching the problem might be different from how you are approaching the problem. So never ever try to use other people's features. They may or may not work, and if it does not work, you will get demotivated that the feature is not working. So it's everything is a combination, right? It's normal day to day life, that how you think, how you solve an actual problem, what is your thought process involved behind solving that problem is what matters. And similarly, just do it for your machine learning model as well. So a few things to remember. uh, well well we have when we have in the data set, we have a mixture of categorical and numerical variables. So typically when you have categorical variables, people often have this question, and even I have also tried to search a lot that what is beneficial, whether it's one hot or label encoding. What I have observed is, if you are using any kind of complex or black box model, let's say random forest or light GBM, usually label encoding and one hot encoding does not make much of a difference. So you can go ahead with label encoding. But for linear models, it is always preferred that you use one hot encoding. And um, also, when you are trying to find correlation for categorical variables, please do remember that it is not through uh, Pearson correlation that you try to find out the correlation between categorical variables. Try to use chi-square test and other techniques that might be useful to understand the relationship between categorical variables. So these are some of the things which you can note down, and you can try it on your own when you're solving a problem. Next thing is whether normalization is required or not. So well again, if you are using simpler models, normalization is preferred. You can try min max, you can try standard scaling or anything. But if you're using a boosting model or a bagging model, usually I have seen that normalization does not have much effect. It may or may not have effect, but I have seen that it does not really have much effect when you're using a black box model. Third point is the process to fill up null values. So again, there's no thumb rule in filling up null values. People have different opinions. You can fill it through KNN. You can fill it through mean, mode. or anything. But what I have seen is for categorical variables, in very few cases, I have seen that if you are using mode transformation to fill the null values for categorical variables, sometimes those categorical variables have turned out to be important, right? Now, and the last point, before I go into in-depth of feature engineering, is anomalies or not. So anomalies, removing anomalies is an important part, obviously is an important part, but then you might be knowing that not all anomalies are anomalies. So how do you differentiate that what is an anomaly and what is not an anomaly? Now, let's say you are trying to predict the gender. Let's say you have certain columns. Let's say you have age, you have weight, height, and some more. Now in the age column, you have a value, usually the range between 5 to, let's say, 80. Now in the age column, if you see a variable which is like, having a value of 200 or 250, then obviously it is supposed to be an anomaly, because we have not heard any human being living up to 200 or 250 years old, right? So in that case, how you can treat the anomaly? Maybe you can do a box plot, or you can have a z-score transformation to understand that, you know uh, whether it's an anomaly or not. And z-score and box plot, and there are some other techniques also, like isolation forest and all, which you can try to remove anomalies. But then what is not an anomaly? So let's say uh, a bank is trying to build an application which can help them predict whether to disburse a loan or not for a particular customer. Now in the data set, you have a column monthly income, let's say. Now in that monthly income, you have a range starting from 10,000, which goes up to, let's say, 100 crores, right? Now 10,000 will have only 4 zeros, whereas 100 crores will have almost 9 to 10 zeros, right? Now, in this case, if you do a z-score transformation, it is highly likely that 100 crores will be classified as an anomaly. Not only z-score, any kind of anomaly detection technique that you try, or even the box plot, it is very highly likely that 100 crores will be classified as an anomaly. But but if you if you think it very realistically, there are many people in this world who are earning crores of money, right? Earning millions and billions of money. So if you compare Elon Musk's salary with your salary, obviously Elon Musk's salary is an anomaly, but then it actually exists, right? So in that case, you need to understand the column. You need to uh, investigate whether it's an anomaly or not. And before jumping on to the problem statement, in every competition that you do, everywhere there's a very detailed description of the feature columns. So just read through them very carefully, what that particular feature column means, and try to understand that what value can be an anomaly and what value cannot be an anomaly. And one thing which is not there in this slide is a multicollinearity thing. So multicollinearity is when you have 3-4 variables which are highly correlated amongst each other. Now, whether to drop them or not is again a very tricky question. So usually what I do is I try to combine the 3-4 features and derive one feature which keeps the information of all the 3 or 4 correlated features. Or else I drop, let's say I have 4 highly correlated features, I will drop 3 of them and I will keep one. Now how to decide on that? Well, keep that one column which is having the highest correlation with your target variable, which is your class y variable. Keep that column which is having the highest correlation with your y variable and drop the rest. Now, usually if you're having a very high correlation amongst each other, then it is mostly likely that the y variable will also have a very similar correlation, right? Or else you can try a simple reduction technique. So you just keep all the valuable information out of your n number of features, highly correlated features, and you keep that. Also, it has happened. It's also in very exception cases I have seen that, you know, there have been cases where I have kept all the columns, and multicollinearity did not really affect the model much. Although in that case, the model must have been a very complex model. So in case of complex models, multicollinearity has has obviously chances to impact, but then it may or may not impact. That is something which you will have to do through train test validation and see if dropping that feature, if combining those highly correlated features is actually having any impact on your validation scores. So this is these four things that you see over here are mostly, you know, in forms of heat and trial. So it's an empirical process. You need to try and test out different things. You need to experiment, and then only you can conclude. So in one problem statement, it might happen that one hot encoding is working very well, whereas in some other problem statement you might find out that label encoding is working very well. Now in case of categorical variables, let's say if you are having a very highly imbalanced distribution, let's say a column yes or no, you have 1,000 rows. Out of the 1,000 rows, mostly 900 rows are yes. Then you know you can just simply yes, no, and let's say there's a third option, three categories A, B, C. Now in that, if you see that A and B are mostly dominating, then you can simply do a one hot encode. You will have three columns A, B, C. And if you see that the ratio or the count of C is very nominal, almost negligible, then you can simply drop that C column, right? There's no impact in those cases. So now the most curious question that I also had when I started participating in competitions is, how can I top an ML competition leaderboard? So first of all, topping or getting a good rank on ML competition leaderboard does not happen overnight. For me, it took at least almost around 1 year. So when I started participating in competitions, I usually used to come at a rank of around 150 to 200. And after 1 year, gradually, when I had this understanding, when I had these learnings, I was able to get a decent rank, usually within top 10 or top 5. And that is something which you also need to stick to. So if you are thinking that, after trying 5 or 6 competitions, you are still not able to get into the leaderboard, then don't just lose hope. That is where you need to stick around. If you solve around 20 to 25 problems within a span of 1 year, you will get a lot of learnings. And to be very honest, participating in competitions, solving different problems, there's no better course or there's no better training or certification than that. It is the best way that you can learn. Even no YouTube course can, give you that hands-on practical experience, that how you can top a leaderboard, right? So like I was mentioning in the beginning, usually in a competition, the training and testing data set will be in a much cleaner format, in a much structured format. So that deep pre-processing is usually not required when doing a competition. Uh, Once you have the data pre-processing done, you simply jump into the feature engineering, and that is where I spend most of my time. And model selection, hyperparameter tuning, and assembling are the final steps, right? After you have the set of features, you can try and experiment with different models, different parameters, and finally you can do an ensembling. Now you can see data QC over here, right? So I know there are a few college students and a few freshers who are present here. Data QC basically stands for data quality check. Now, data quality check is a term which which at least I became familiar with when I started doing my internship and when I started doing my full-time job. Usually when I used to take part in competitions, I did not do any kind of data quality check because I was not aware of the term. So data quality check is something like, when you're having the training and testing set, just make sure or just have a look that, there's no certain data drift. So data drift is something like, let's say, in your training set, the values range from 0 to 100 for some features. Now that 0 to 100 should not become 500 to 1000 in your testing set, right? If there's such a difference, such a big gap between the values of your train and test set, then that's what you call as a data drift. So usually the competitions take care of that, and that is why, when, even though I was unaware of the term data QC, I still was able to, directly do the pre-processing feature engineering and build my model. So data QC usually in competitions is a very small, small time investment. So you can do it. And also there have been cases, right? In many of the machine learning competitions, you must have seen that people getting a very good score, very high score. The reason being that uh, there can be a data leakage. So what data leakage means is there might be some rows which are present in training set as well as testing set, or there might be a lot of duplicate rows, and these are some of the checks you can do. These sometimes turn out to be very handy in some cases in some competitions, because in competitions it is usually just zero point 0.1 or 0.01 difference, which creates, which moves the rank up and down by almost 50 or 100 positions, right? If even if you're having a small difference of zero point 0.1, you might go into the top 10 and so on. So those kind of small quality checks, whether there are any duplicates, whether there's any intersection between the data points that are there in your training and testing set. So these are some of the checks you can do. And pre-processing, I already mentioned the way you can do the filling up of the null values, you can treat anomalies and so on. Feature engineering, I would always suggest that, you take up your y variable, and with respect to that y variable, uh, you try to take each of the features, try to plot graphs, try to understand that, if that value, try to bin those value, try to categorize. Let's say you create three different categories, let's say for income only. Let's say you have the income ranges. Now categorize into three parts: low, medium, high. That low, medium, high threshold you can decide on your own, and try to see if there's any pattern or correlation with the y variable and so on. And obviously most important is think like a human. It is a very underrated thing. I have not seen it anywhere, but if you can directly relate yourself with the model, I think that's going to be a huge thing. It really helps you understand the problem in a better way and also create a better machine learning model. And I'm sure there are a lot of Kaggle grandmasters out there, Sudalai Rajkumar, Abhishek Thakur, and so on. I am pretty sure they also know the techniques. Maybe they have even better techniques. But for now, I thinking like a human has been a really good thing. And also, please keep this in mind that what features will work for you may not work for some other people, and vice versa. So please trust your approach, and do not do not just randomly change your approach because someone else is creating some other features and they are getting better results. And once you have that feature engineering done, you have the model selection part. So the best way to evaluate models is start with a simple model. When you're creating a model, don't jump into XGBoost or LightGBM directly. Start with a simple model. Do a logistic regression. Do an SVM classifier or SVM regression, right? Then step by step go ahead to decision tree classifier, then random forest, then XGBoost, and so on. Why this will help is this will help you understand whether the model is actually having an impact or not. Well, when you are having very less number of rows, it's a thumb rule. Usually we use bagging or boosting models when we have decent number of rows. Let's say, probably I used to use bagging or boosting models only when I had like more than 5,000 rows. But obviously, even if you have less than 5,000 rows, bagging and boosting will or may work really good or really better than linear models. So there's no thumb rule or there's no hard and fast rule like that. But start with a simple model, because that will help you understand. And then finally, you come down to hyperparameter tuning and ensembling. Hyperparameter tuning again is a very empirical process. It's again a hit and trial process, so you need to keep on tuning, keep on testing. And finally, when you have linear models and different models, you get to understand that what model is working, how the models are working, and which model is working with respect to certain set of features. So let's say you build a feature set of 10 columns. You see that your linear algorithm is really using the first five features very good, and it is able to capture pattern from those five features, whereas your boosting model might be capturing information, more information from features 6 to 10. It might be a possibility. So in that case, it will help you understand that, which models should you ensemble. Because uh, let's say, because in case of a competition, what happens is you are getting 89% accuracy with XGBoost, you're getting 89% accuracy with CNN. But if you have a look, the prediction labels will be quite different. CNN prediction labels will be a bit different from XGBoost, and XGBoost will also be a bit different from CNN. So in that case, it will help you understand that which model should you combine, right? So XGBoost plus logistic regression might surpass XGBoost plus CNN. So you never know. That is why always start with a simple model and you try to create different models and understand, right? So don't just jump directly into complex models. And when solving a problem, please spend most of your time into feature engineering. So that is what I had for the theoretical part. I will come into the practical part. So before I go on to the practical part, I think if there are any questions, I would be able to I can answer them and then go on to. So like I was talking about, so I have two use cases. The first one is a hands-on walkthrough of the ZS internship contest that I had. So the problem statement there was to predict people who are turning antisocials because of social media usage. Now, the business use case was that famous social media companies, they basically wanted to identify people who might be leaving social media due to some reason, so that they can lure them back and help them continue using their app, right? So people who are turning antisocial, the social media companies will try to target them, and they will try to reduce the churnout rate. So I will jump onto the notebook quickly. Now, this is how my training data set looks like. So I have around 2200 rows and 22 columns. And if you see over here, uh, this is my y variable. This is my turn antisocial y variable. Now, okay, this is the set of features that I have. So I have total Facebook statuses, I have account membership period, service support calls. Service support calls was something like if something is not working, then the number of calls that the customer used to make to the customer helpline. Number of snaps, so number of snaps was related to Snapchat. Total WhatsApp charge. So all this charge column that you see, total Facebook, total WhatsApp, total Twitter, is something, if you see, it is the famous social media companies. They are charging people a small amount, and that they don't want to miss out on that charge, right? They don't want customers to leave. So that is why they want to understand that who are going to leave and still keep them. So this charge is basically the price these platforms are charging to their customers, to, that is their kind of business model. Like Facebook uses advertisements, Instagram uses advertisements, and so on. So these are the features that I had. And obviously, if you can see, there are some null values as well. Now let us for a second forget that what features or what kind of variables are there. You think as a human being that you want to identify people who are turning antisocial. Now social media is an addiction, right? It's like a drug addiction. So if you think very carefully, when people are spending too much on drugs, usually they get very addicted, they have a health issue, or else they are spending lot of money on drugs. Later on they realize that no, they need to cut it off, or they need to reduce it, or whatever, right? Or if you're having a health issue, then you need to stop, right? So if you think very carefully, it's like if you abuse that particular thing, then there's a high chance that you might reduce it or you might cut off. So my analogy when I was trying to solve this problem was that there might be people who have been using social media excessively, and there's a high chance that they might be cutting off, because it might be having a harmful effect on their health or on their mental health or anything, right? And this analogy for me, this thought process for me actually worked out very well. So so based on this thought process, or based on this hypothesis, I created my set of features. Well, you have I will share the GitHub link, so you can have a deep dive into the code. I won't go into very step by step thing because of shortage of time, but simple things like, like I was telling, to check the correlation, to check if there are any multicollinearity. So that is the first step that you should do. Try to understand which variables are correlated. And if you can see, with turn on antisocial, there are only few columns which are decently correlated, and there are a few columns which are not so highly correlated. And again, this is I have taken out those important columns which seemed to be very important. And if you see total email charge and total email characters, this is having a very high correlation. Now next, what we do is we try to understand the different data types. Accordingly, we will have to fill up the null values, and that is the reason we should get to know what is a categorical variable and what is a numerical variable. And if I go on to the uh, yeah, so here in this case, what I did was I filled the null values with the mean. So all the columns which had null values were mostly numerical columns. So these were the four numerical columns which I had, and so I just decided to go ahead with the mean. And feature engineering is the one where I focused in this problem. So first of all, I tried, like my analogy is that if people are abusing it, then they will cut off. So there's a high chance that they will turn out to be antisocial. So I try to understand that what are the platforms that they are already onboarded on, right? So Snapchat plan and email plan, it was a category, it was in form of categorical variable. So I just converted into numerical form, and I mean, I just converted to 0 or 1. And this is where I come up with my features. Now average character in WhatsApp message, right? So what I have is I have total WhatsApp message characters. I have total WhatsApp messages, right? Now total WhatsApp messages, I might write hundreds or thousands of messages, but all my messages might be lengthy or might not be lengthy. So getting to understand that what is the average character, what is the number of characters that I'm using on an average, will help me understand that how much time I am spending, right? So let's say you are texting on WhatsApp, you type hi, hello, yes, no, right? These are 4 or 5 messages. Now I type in my name is Debadri, I am waiting over here, please come down, I will be leaving in 20 minutes. These are lengthy texts, right? Number of messages I typed is also 5. Number of messages person X typed is also 5. But I will be spending more time into the platform because I am typing more lengthier texts, right? So that is how you need to understand. I have my analogy, you might have your own analogy. So I also have the data sets in my GitHub, so please feel free to download them and try out your own thought process. Create and one more good thing which I forgot to mention is create an Excel sheet, create a column having the hypothesis. So you have a column hypothesis, write down your thought processes, write down your own hypothesis that this is what I believe might happen. Write down 4 or 5 hypotheses, try to prove it through the data, try to see with whatever hypothesis that you are having, are they actually matching it, are they actually true? If not, then what is true, what is not? So please, this is a very good practice. Create a set of hypotheses and try to validate in terms of data. So my thought process was this, and like abusing here in this case would be overusing the social media or spending too much of time on social media. And that is why average character in each message was a very good understanding that this person is using up a lot of time. Similarly, the other things are like number of snaps, and if a person, we a lot of us already have so Facebook accounts, use Instagram accounts, right? But not all of us post on those platforms. Many of us simply have that account, we just scroll, we just see, we just consume the content, we don't post anything, right? So that is again something which I was trying to see whether uh, whoever is having a social media account, are they doing any kind of activities, are they actually posting anything or not? And once I have this set of features, I go ahead and simply build my model. And once I have my model, what I do is I try to plot the feature importance, right? Now, this is again something that you also need to do. Like I said, selecting the final list of features and trying to understand that what features might work and what features might not work is a hit and trial method. But then uh, just stick to your hypothesis, stick to your analogy, create features based on that. On top of that, you can do certain modifications. But what analogy I had in my mind was that if people are spending too much of their money on social media, then there's a high chance that they might cut off. And that is something which kind of turned out to be true in my case, right? So it might have a positive correlation or a negative correlation with my variable. So it might also happen that people who are using excessively, they might continue using it, or they might also cut off, right? So I think I had done this set of checking somewhere what is the correlation between the variables. So if you can see over here, uh, I have total charge, and I have uh, my turn on turn antisocial. So it is kind of having 0.21. And and initially, if you see, whatever initial variables that I had, it did not really have much of a high correlation with the y variable. So total charge, this kind of proves that in many of the cases, positive correlation is something like, if people are spending too much, they will probably continue spending too much. However, although my hypothesis turned out to be false, but then in the opposite way, it actually turned out to be true. So this actually turned out to be a very important feature. So my analogy that, the total amount spent will have a direct correlation with the y variable actually turned out to be true. And I had a very good feature importance on this variable, and also whatever other features that I created, average character, to understand how much time is being spent, is they also had a very good feature importance level. So this was the first problem statement, or rather the first use case that I have done. So you can head on to my GitHub, download the problem statement and do it on your own. And the second use case that I would like to quickly cover is the Brainwaves hackathon that was organized by Society General. So in that Society General hackathon, it was basically, the problem statement was basically to understand or classify complaint status based on customer feedback of resolution. So when we raise a complaint, once that complaint gets solved, usually the company will send out a feedback form or a feedback email. Now, most of the time, usually we don't respond, but there are people who actually respond, who actually give feedback to the complaints, whether they have been solved or not. And that is something which in this use case was to analyze customer satisfaction levels so that they can keep the best churn rate, so that customers don't leave uh, their platform or their services, right? um, so here again, quickly showing you the data set. We had the consumer complaint summary, we had these columns. Now all of these columns were categorical variables. We had certain null values. Also, in your data set, that's a rule of thumb. If you are having, for a particular feature column, if you are having more than 30% null values, I usually drop them. I don't find them to be meaningful, and that has really not impacted. Like, keeping those columns for my model has really not impacted. So usually I drop all those columns which are having more than 30% null values. And this was my my class distribution. So as you can see, there was a very high imbalance in the class. And once I had the text, I had to build one model primarily based on the customer feedback. And along with that customer feedback, I also used certain features like the number of the number of words that the customers are using, average length of the word, number of unique words. Now, why we are using this? Again, for a second, just think from the bank point of view or from a human being point of view. When you raise a complaint, if that does not get resolved, you are usually very angry, right? You come up with a feedback, you write very long sentences, you use harsh words, and you typically mean that your uh, complaint resolution was worthless. You can't do that, you are a very bad company, that company is better than you, and so on. So this is common sense, right? That's why I thought that, if the customer is writing long summaries, it might mean that he's actually trying to mean something, right? If it's a good resolution, usually people will write, okay, I mean, good job, or the resolution really helped me. Usually they will write short sentences. Most of the cases, I'm not telling that, if you're having a good resolution, you don't write summaries, but usually you write one word or two word or one sentence, right? So these are some of those numerical features that I created from the summary. And also, now since this was a banking related problem, so here again, tuning the TF-IDF was very important. Now again, think like a human. When you go to the bank, usually what do you say? You say that your ATM card is not working, or your bank account is not working. You're not able to withdraw your money. right? So if you think very carefully, you are using bigrams or trigrams, right? You're not telling money, you're not telling ATM. That does not mean anything. You either tell bank account, you don't tell bank is not working. You tell bank account is not working. You tell ATM card is not working. You tell your account pin is not working, right? So just think from that point of view. So in this case, don't you think that bigrams or trigrams will be more beneficial? So again, this is also something which I thought and I came up with. And as you can see, so my leaderboard score was really good. So again, for this problem also, you have the data set, you have my code, everything on GitHub. I will share the GitHub link and everything, so you can just go through them. And before I take up the questions, one last thing I would like to mention is, as you know that Pfizer is one of the largest pharmaceutical companies in the world, and they have made a huge impact during the difficult times during the COVID. So Pfizer is also doing some great stuff, some great projects in data science and machine learning. So please feel free to upgrade your skills and reach out to me on LinkedIn. If you find any suitable role available in Pfizer career page, I will be happy to refer you. Yep. So that is the end of my presentation. So I can take up the questions. Will you speak about using auto encoder and VAE to create new features? So this was mostly about art of feature engineering. So I would like to tell you that, you can obviously use auto encoder and VAE is variable autoencoder. Okay. So yes, obviously you can use it, but then first thing first. So like I mentioned, don't just jump into complex stuff. Think in simpler terms, and step by step, if you do it, you will get the clarity, right? You will get the clarity what is working and what is not. So that really helps you in understand. So start with simple, then move ahead to complex methods. Can you give more examples of famous data sets? Okay, so see, in case of competitions, usually Kaggle and all, they design the problem statements in a way that you use more complex models, you use deep learning models, and so on. But in real life industry cases, I have seen in many projects where linear models have surpassed the normal gradient boosting or any kind of bagging boosting models. I'm a fresher, so I want to try until. So, Shritej, see, you can obviously take others' projects and do, but try to add something from your side. Okay, doing just normal copy pasting won't get you anywhere. So, try to add something from your side, and that would be really helpful. Uh, and obviously, you can try creating notebooks on Kaggle. Kaggle is a really good platform that you really helped me a lot. Can we use label encoding for predictor? Yes. So what you mean to say is target encoding, right? Okay, it's an anonymous attendee. Can we use label encoding for predictor? So label encoding for predictor is basically target encoding. I have not used targeted encoding much, but obviously whether to use target encoding or not is to understand through the EDA. So that is again, it is depending upon you, but my point is to think like a human. Okay, that is very beneficial. There is no point in keeping variables which have multicollinearity. Yes, there's no meaning. That is what I told, right? You can do a dimension reduction technique and keep the maximum information from those highly correlated features, or keep any one of the correlated features, and so on. But again, in some of the exception cases, machine learning is more of experimentation. In some of the cases, I have seen that keeping two or three highly correlated features have improved the scores, but that is very exception. I would suggest you go ahead with dimension reduction or drop those features. How features to consider our model? So again, you can do that train test validation. Try to see what is the feature importance given by the model, and also try to see the correlation between the target variable and the features. If it is having negligible correlation, then there's no point, right? Then there's no point. How to participate in ML competition? I think you can head on to Analytics Vidya itself. They keep on hosting a lot of competitions. Also on Hacker Earth. Hacker Earth also keeps on hosting a lot of competitions. I would suggest keep Kaggle for a later stage, because Kaggle is very advanced. Even I took a lot of time to become a Kaggle expert in competitions. So please take it slow. Don't get demotivated. In data some outliers, but they are in as per client. So again, Vaibhav, how to handle those outliers? There are outliers which client suggests you to keep, right? So maybe you can do a normalization to bring down the range, or you can just simply keep those outliers because they might be of some importance, right? Or you can, or like I said, you can try to create those binning and categories like high, low, medium, something like that. Should we consider features which are correlated? Yes, you need to consider features which are correlated with the y variable. If they are highly correlated amongst each other, then do a dimension reduction or keep only one of those important things. You are trying to measure involvement of a user by the time she spent. You measure that with the average number of words spent. So if right, so Shovik, what you have asked is yes. See, it's so I am not considering typing speed, but it's like a common sense, right? If you are using if you're using lengthy text, you are spending more time on the app, right? Doesn't also depend proper using more number of doesn't it also see, it does not. I am trying to understand the time that they are spending, right? It does not really matter if they are using the correct words or correct. There might be people who use 100 emojis. They don't use a single text, right? Now, finding that 100 emojis, typing that 100 emojis will obviously take more time than than putting out a hi message or a hello message. Okay, so since we are running short of time, I will quickly share the links. How do you calculate correlation before mapping categorical variables? So you can do the chi-square test. That's a very good technique of understanding which categorical variables are correlated. And also maybe you can do a one-hot encoding and try to see if it has any correlation with the y variable. How I know in imputation the input mean median or so on. See, Shankar, how you do the imputation, like I told you, there's no hard and fast or there's no thumb rule, right? You just need to understand. So usually in let's say you are trying to fill in income of null values on an income column, then it is very difficult to do. It is very difficult to put in a mean value. I mean, you can put a mean value, but I would suggest you go ahead with a median value in that case. Now these are some things which will come from more practicing. There's no like I said, there's no thumb rule. You just need to practice and you need to understand, and you can try different imputations and see how it is impacting your validation results. Do we drop instances where target values are null? Yeah, if your target variable is null, then you obviously need to drop those rows. How I participate in Kaggle competition? Kaggle competition, you can keep it as a secondary thing. I would suggest you first try with easier platforms like Analytics Vidya and Hacker Earth, and then go ahead to Kaggle competitions. But just a suggestion, in Kaggle competitions, try to go through the discussions, because the discussions have a lot of valuable inputs. So it is very important you go through the discussions. Half of your problems will be solved there. For a fresher, how much depth and concepts to cover in ML is deep learning necessary? So depth and concept, you need to understand maths and stats. When I started with data science machine learning, I did not have that level of guidance. And since I learned on my own, one thing is very important. Don't just jump into dot fit and dot predict. That is something everyone can do. Please try to understand the basic of statistics. what is anomaly, how to treat anomalies, how to treat mean value, what is correlation, what is multicollinearity, and how you can create, how you can get valuable insights from the data and so on. So it is very important that you do that. Uh, and So don't just jump into dot fit and dot predict. Everyone has equal exposure to using light GBM or transformers model, but it is how you handle the data, how you pre-process the data, how you create features, what insights you are able to get is what differentiates you from the others. Is there any other method to other than using mode? Yeah, you can use for filling up categorical variables, you can use KNN as well. You can use forward filling method, you can use backward filling method, or you can also use your own things. Like what I have done is, in case there are in case of categorical variables, there's a decent, let's say 10 or 15% of the rows which are null. What I have done is I have simply put missing as the value, right? So you can also do that. I was wondering, while we do the model selection step, should we choose only one model and proceed? Should I select the all? Okay. When you're trying to do the hyperparameter, you can select one model, do the hyperparameter tuning, then go on to the second model, do the hyperparameter tuning, and so on. Take it one by one. How I know in imputation missing null wala input mean. Yeah, so well, I already answered this, that how to understand which imputation method is good. Suggest some site to prepare for data scientist interview. So, well, I used Analytics Vidya, to be very honest. They have very concise content. It is very helpful. Analytics Vidya is very popular across the world. So please feel free to use Analytics Vidya. And rest, you need to have the concepts, because it is not possible for even Analytics Vidya to predict what company X will ask you, right? So keep your concepts ready. How do we handle class imbalance in real world, upsampling or downsampling? So see, usually in case of imbalancing in NLP data sets, usually upsampling or downsampling or any kind of oversampling is not beneficial. NLP is a different kind of data. So I usually don't do any kind of oversampling, because text data and numerical data is very different. So there it does not really help much. But for other kind of data, yeah, downsampling never, I would suggest you never do downsampling, because it's loss of information. So it's always suggested you do upsampling. You can try random upsampling, or you can try smooth upsampling, anything. Heart disease prediction model accuracy improvement. Could you tell us where we find good feature engineering techniques for this? So see, heart disease prediction, you cannot find any features like that in the Google, right? So you need to understand, you think, I don't know what data you have, but think, like, what is the cholesterol level. If you have this information, think that what can be the cholesterol level of that person, what is the height is to weight ratio, right? I am not a doctor, but these are some common senses, right? So think in those terms. Suggest some times to prepare data science interview, how to start NLP. You can start with Stanford NLP. Those YouTube videos and the content present on the Stanford website is really helpful. Using one ML algorithm, I predict value. The last prediction failed. I knew to check the applied. Okay, so you need to get the labels from the test set and the training set, and need to check where there have been mismatches. Now, obviously, don't expect your machine learning model to perform 100%. So there will be errors in your model, and that is what machine learning is. So yeah, I think I have covered all the questions.